Hello. Internet was out. Hey, Friday, September 8th. Just came back about 3 o'clock. I know many of you may have worried about me that I was not okay. I was not able to get any information to anybody until late. And the person, my boss, um, Teresa, did not have internet either. So it wasn't just me. So I wanted to let you know that, and finally she was able to get to leave an announcement. So it caught me off guard. I was ready to go and did not did not happen until 3 o'clock in the afternoon. So here it is, about 3:30. So this, if you can watch this on Saturday, it'll count toward your hour for Friday. So Saturday counts for Friday. So good to know. Um, let's get started. We're going to be doing the bonus assignment and we're going to do, let me do this here. So we're going to be doing the bonus and I'll give you a link to this bonus. The bonus will be, let me go here. Let's make this large. Bonus will be the phet state of matter lab. So this is a bonus while going over this phet state of matter lab. So I'll go over the answers to that. Do that. And let's make that look like state. Then I will review REV, IEW, W3, assignment 2, phases. So remember, try to get everything done by Monday. Due by Monday, because Monday at 11:59. Remember, 59. It's auto graded, so it automatically gives you a 0. So try to stay current for week 3. We're going into week 4, and I will see you Monday. Hey, Janaya, how are you? How are you doing? Let me pause this for a second. Okay, so let's take a look at what we have here. So in this lab, and what I'm going to try to do is show you a split screen of this. Okay, so we're going to do the states of matter lab, and this is kind of an interesting thing. I'll give you a little introduction on it. I'm going to turn my screen off because I'm going to be turning sideways a lot. Okay. So this is in the Nearpod. I will have that posted for you so that you can do this assignment, get it done. So there are 2 parts to this. And let me see if I can go here. Nope, nothing here. Okay. And what it is, so the states of matter are known as the phases of matter. When something changes from one phase to another, it's called a phase change. Example, solid ice melts into liquid water. Because our simulator is a closed system, you will notice that the changes in temperature result in change in pressure and vice versa. Adding particles will also have an effect. When you decrease both temperature and pressure, and even add particles, just be careful, it can blow the whole thing up. So a closed system is we keep everything inside. So let me go to this assignment here. There's the phet lab. So we're going to start with, we have 2 things that we're going to use. We're going to use the states of matter, but we're going to start with a phase change first. So we're going to do that. And if you'll notice, there's a finger here. Okay. And I can push down on this or pull back up. There's temperature in Celsius, and there's temperature in Kelvin. Kelvin is one of the measurements that we'll be talking about. We don't need this phase diagram here or the interaction potential. All right, and we have a pressure gauge. So, and then we have a pump to add more molecules or atoms. So we have water, which we're going to be talking about mostly. And we have also oxygen or neon, argon or neon. So we're going to be talking about water. And we're going to put this to Celsius. So this is pretty cold, 127 degrees Celsius. So we have some vibration here, and this represents a solid. Okay, so I'm going to give this a split screen here so that I can show you both these things and also the assignment that goes with it. Okay, let me pause this a second. All right, so I'm back on. So I have the pressure on this one side, and I'm using water molecules. So I've given you some examples on here. So it says experiment with the changes in temperature and pressure, then fill in the chart below. Experiment with the simulator to discover how temperature and pressure are related. Experiment with all four substances and write the laws. So here it says increase the temperature, and we can do that by just adjusting this. Okay, so if we increase the temperature, we add heat, and as we increase the temperature, all right, you can notice that the molecules are moving faster and faster, right? Temperature is going way up. And you'll also notice the pressure going way up, 4.9, 5.0. So we're adding so much the pressure that the molecules are bouncing against the walls and they're adding more pressure, right? So remember, as we add kinetic energy, the attraction between the water molecules goes down. There's some spinning, some rotating, some bouncing, right? And I can get it so that it'll continue it'll blow the top right off. This is a closed system. So as you can see from my first answer, as the temperature increases, the pressure increases. So that's what we're saying here. The temperature increases, the pressure increases. And I write a law as an increase in temperature causes an increase in pressure. All right, so let's take a look at the next one here. A decrease in temperature, try to cool it down. So let's do that. We're going to cool it down. All right, so we are at 28 atmospheres, and look what's happening to the pressure. Okay, 21 atmospheres, 23 atmospheres. I'm cooling it down. The kinetic energy is coming down. The motion of these materials, the water molecules are going down. Temperature's going down, right? So that's what we're trying to do. We're adding cold to it. And the pressure is gone down to 8, 7, 6. Okay, and you can see the kinetic energy is less. The attraction for the molecules is increased. So in this particular case, let me just say this, that the temperature, can I write that? I hope so. Temperature went down. The pressure went down. The kinetic energy went down, and the attraction between the molecules went up. Okay, so that's what we have here. So we're going to type in this particular spot here. All right, so I'm going to type. All right, I'm going to use this. I'm going to type pressure decreases. Decreases. And I'm going to use my pen here to put a blue arrow. Let's make it, is that blue? There's blue. A blue arrow. It also decreases. All right, so, and then I'm going to put in this, a small word here if I can. And this one says, let me give it this even smaller type. Let's do 14. A decrease in temperature causes a decrease in pressure. So I'm going to put decrease in this particular one. D-E-C-R-E-A-S-E. Did I get it? Sure, I did. A decrease in temperature causes a decrease in pressure. Right? We saw that. It went down, went down. Okay. So let's look at increasing the pressure. So we're going to clear this out. So we're going to increase the pressure by pushing down on this. Right? So if we increase the pressure, what do we notice about the temperature? So we notice the temperature is rising. So you can see the pressure is going up. Okay, we're squeezing, squeezing. We're making those molecules, pushing them together, closer together. So we're forcing them together, and that increases the temperature. It increases the kinetic energy and also increases the particle distance. So they're going to attract each other more. All right, so, okay, so that, I'm going to let this down. Okay, so let's do that. Let's put this in here. Let's type in increase in pressure. What does it do to the temperature? Let's make this about 18. And we'll say it also increases right? Increases. I guess I could make this even bigger. Let's make it 32. Increases. All right, so I'm going to put an arrow in this particular one. So let's do this in red. Okay, red arrow increases. So I'm going to type in here the pressure, up increase in the pressure causes an increase in, let's go down to 14. So this one says increase. And this is an increase as well. Oops. You say if I can type this right underneath it. Maybe I can. If I hit enter, increase. So I've got increase and increase. All right, so let us go ahead and try to decrease the pressure. So let's do that. Let's decrease the pressure. So to decrease the pressure, I'm going to lift up on it. And you see that it was 1142 Kelvin. I'm going to put this to Celsius here. So it's more 869 degrees Celsius. And as I pull the top up, I give it more room. Particles are moving and the pressure is dropping. And what's happening to the temperature? Temperature is also dropping. So let me kind of go there. So let me say this. Oops, try this again. All right, so to lower the pressure, we lowered the temperature. The bicycle pump seems to keep doing as well. Okay, so it might be easier for me to, let me just type this. It'll be easier for you guys to see it. So I am decreasing the pressure. So I'm going to put it, I think I'll try to do it this way. Decrease, decrease, and then I think I can get it. Let me move it over and decrease. All right, decrease and decrease. So a decrease in pressure. Let's put this arrow. I'm going to use this, not this one. Okay. I'll use a blue. Decrease gives me a decrease. All right, and how I write this is I write this and over here, it type to about let's say 14 again. Decrease in pressure causes a decrease in temperature. Okay, let me get this, enter, and let's get this in a little bit bigger here. All right, so let's go 18. There we go. Decrease in pressure causes a decrease. I didn't spell causes right. So your goal is to answer this last one by taking 10 particles to 10 pumps. So adding more particles, and I'll help you out with this one. Adding more particles, I'll put down in this particular one. Right, so this is going to start out like an increase in particles causes a blank in temperature can't type while I'm doing this and blank in pressure. Okay, so that's what you're going to do in this particular one. Now the next slide, we're going to use the states of matter basics, right? And we're going to use water again. Right, so we're going to go, so here is solid, okay, solid. And let's start the first one. We're going to go liquid. It says liquid to solid. We're going to add energy. So when we add energy, liquid to solid. I'm sorry. We went from, let's do this again, solid to a liquid to a solid. Okay, so here is a liquid, and I'm sorry, we're going to go to a solid in order to get it to go. So this way causes it to go to a gas, right? So what we're going to do is a liquid, we're going to remove heat. Okay, remove heat. Vibration stopping, very little kinetic energy. So we're going to type in here. I'll make this 18, makes it easier to see. Move this around. Remove energy. Maybe 30, 24 is better. Okay, remove energy. And then over here, so let me do this. So type of phase change, liquid to solid. Okay, so if we look over here, so liquid to solid, so we're going in this direction, is called freezing. Right, so that's what we're going to do. We're going to put in freezing using that. Also, you could use this particular one, liquid to solid. Follow the arrows on this particular one. Liquid to solid is called freezing. So we're going to do freezing in this particular case. Okay. All right, so you can see, so let's do one more example. Liquid to a gas. So we got a liquid. So to a gas. So this makes it go to a solid. So we can't cool it. Liquid to a gas. We are going to use some heat. So we're going to add energy. Add energy. So let's do that. We're going to type in maybe I can just use this one. Add energy. I can make this go single space here. Backspace. Enter. Nope. There we go. I've got it pretty good. So add energy, liquid to gas. All right, so liquid to gas. Follow the arrow here. Vaporization. I'm using colors. I don't want colors. I want text in there. Vaporization. All right, so you should be able to fill out the rest of those. I've got, so you put in remove or add energy. Use this simulation. That was the first simulation. And finish those out. All right, so finally, we're doing the W3 assignment 2 phases. I'm using my graphic organizer from the home page. Right. Deposition is a process that changes matter from, and look what deposition goes from. It is from a gas to a solid. Gas to a solid, right from the graphic organizer. Melting is a process that changes matter. So melting, going this direction from a solid to a liquid. Vaporization is a process that changes from a blank to another blank. So vaporization, a liquid, follow the arrow, it says a gas, a liquid to a gas. Freezing is a process that changes matter from liquid to solid. And condensation, here's condensation, changes gas, follow the arrow to a liquid, gas to a liquid. And sublimation is a process that changes matter from solid to a gas, solid to a gas. And we're all through. Okay. Thank you, ladies and gentlemen. That's about 26 minutes for me on there. I hope that helps you get your work done if you haven't gotten it done before. Thanks so much. Have a nice weekend. Love you guys.